Alright, here we go, mounting the part in the fixture. First we got to take the previous part out. We got to back off this one steady rest jaw to get the part out. Back off the tail center, and then I've already loosened the nut on the end of the fixture. I didn't show that, but I normally have to loosen that nut too. Put the straps on to lift it up out of the machine with the crane. It's not really that it's that heavy. It's just kind of awkward to get in and out of there without using the crane. The light above on the roof of the building above the machine is kind of acting up in this video, and you'll see it blinking off and on. That's what that is. So I got to take the straps off, and there's a little insert like thing in the middle of the fixture that supports the middle of the part on the steady rest as it rotates, because of course half the tube is cut away. This is that part that I made the straightening fixture for in the previous video. The customer doesn't totally like me showing their parts, but I don't think you can see anything that means anything here. I'm just taking the part out and putting the next part in the machine. One thing about making a fixture like this is if you ever put threads on the end of it, make the threads kind of sloppy and loose, because shavings inevitably get in there, and I think I made that fit kind of too tight, and I'm always struggling with that nut getting it on and off of there. This is the little plug on the end of the part. It has kind of like 3 keyways that match the fixture to keep it from twisting the part as the nut is tightened. We just got to clean things off. I think about 50% of machine work is cleaning things. You'll get a part that's been straightened, but it hasn't been machined, of course. There, where I plasma cut the piece out, it leaves a little bit of slag or dross along the cut, and I have to kind of clean it off here. Just kind of knock it off with a hammer here. That's what I'm doing. So it's not very much, but I need to knock it off, because it's going to give problems for the first tool that roughs off the remaining material, and the tool just lasts longer if you kind of bust off that slag left from the plasma torch. You got to clean out the inside of the part. It's got debris from the plasma cutting in there, like dust or whatever, it leaves this kind of soot too. Now, of course, the first part or the only part that I've decided to video, I have difficulty getting this mandrel back into the part. All the other ones it slid right in, but of course the one I decided to video record, it binds in there, and I have problems with it. All the rest of them, I did 20 parts. It didn't have this happen, but on this one part, normally it'll just slide right in there. So I had to kind of hammer it in a little bit. It came out easy enough. There must have been something there, maybe a piece of dirt or shaving or something, causing it to bind a little bit. When I took it out, it slid right out of there. So I have to kind of get it lined up, not perfectly, but a little bit close enough so that it cleans up all the way around. It's got about 1/4 of an inch of material coming off all the way around the part. So I'm just putting that little insert in there and screwing it in. It has 4 1/4 20 socketed cap screws that hold it on. I got to kind of center it. I can see where the plasma cut left off, or the track I milled. Actually, I milled a track for the plasma torch to guide it. And then I cut it, and then the part springs open like I described in the previous video, and I have to squeeze it back within reason to the original dimension. And that little insert I can kind of eyeball it. It doesn't have to be perfect because there's a 1/4 of an inch coming off. And I have to tap the little end piece in, the end plug, which has, like I said before, 3 keys that keep it from rotating and twisting the part as you tighten the nut. So I snug the nut up here. I'll tighten it further after it's in the machine. See, I'm having trouble with that thread, and the thread was binding a little bit on this nut. Like I said, if you make a fixture like this, put a lot of clearance on the threads, because it doesn't need to be as precise as I've made it. This seems like a relatively simple part, but it ends up being kind of complicated because of the distortion in the material and having to mill this half of the tube away, and then it has to have chamfers all the way around the cutout. Unfortunately, I can't really show you the machining on it. I did make a video, like I said in the previous video, on that, but this customer is a little particular about that. See, I tighten the nut up further, extend the tail center into the end of the fixture, and tighten the chuck all the way. So now I have to readjust the steady rest, and then I have to reset the 0 point on the program for the fixture, because I've taken it in and out of the machine, and there's nothing that really lines it up in the C-axis rotation. So in order to change tools on this machine, I have to close the door. You can't do anything on this machine with those doors open, and they're automatic doors, and it's impossible to override them like some people have suggested in the past, because it's built into the ladder diagram of the machine, and it senses the switches, and it times out, gives an alarm. So I've just had to live with it just the way it is. It's kind of, on a lathe, that's kind of a pain, because you can't polish anything. Like a lot of times you want to polish O-ring grooves and things like that, but you can't run either one of the spindles with the doors open. Now here I'm going to set the C-axis rotational 0, if you will, and then the Z 0 point again. The Z 0 doesn't change too much, but I reset it anyway for every part. I didn't machine these parts, and the length of them is varying just a little bit, or I didn't face the tubing to length. Somebody else did that, I should say. And so, like I said, that length varies just a little, so I just set the 0 again. It probably doesn't need it, but I do it anyway. So now the program's ready to start, actually, but when I bring the first tool in, I check the tool, because it's the tool that does the roughing, and there is that maybe some residue of that dross or slag left, and so it tends to wear that tool out. About every 4 parts I have to change the tool, and this is like the 5th part on that tool, so I'm going to look at it. And sure enough, it needs to be changed, so I'm going to have to change it here and retouch off a new tool. It's a 3/8 4-flute carbide end mill. This particular job doesn't really use a lot of tooling, actually. Mostly just that 3/8 end mill. in the beginning gets worn out. The rest of the tools pretty much last the whole job. So I'm touching it off on the top of the tail center because it, of course, doesn't change there. And I know the exact diameter of it, and I can get the exact height. I touch off tools manually on this machine. Part of the reason is because the laser tool setter never functioned, and also I get an actual indication of where the tool's located on the display on the Mazotrol. A lot of controls don't do that. Most controls don't show you the offset continuously updated on the display, like a Fanuc control or a Haas or something doesn't show you that, but on the Mazotrol it does. So you can see the actual location. So that's pretty much it. Thanks for watching.